Okay, 12.6. 12.6 deals with permutations and combinations, and we'll be talking about these. This is a shorter section. An arrangement when order is important, that's a key word here, order is important, is called a permutation. For the letters O, P, S, and T, the permutations stop and POTS are different because the order of letters is different. So STOP is different than POTS. You can use the counting principle to find the number of possible permutations. Find the number of possible permutations possible for the letters O, P, S, T. Well, for O, S, T, O, T, let's just talk about those four letters. 1, 2, 3, 4. How many letters do we have for an option of the first letter? There's 4 of them, so 4. Now, if we use one of those letters, how many is left for the second option? 3. Third option, 2, and the last option is 1. So now if we use the counting principle, it says we can multiply these together. 4 times 3 times 2 times 1. 12 times 2 is 24, times 1 is 24. There's 24 different ways to write stop and POTS when order matters. Now let's look at this one. Use the counting principle to find the number of permutations possible for the letters water, or W-A-T-E-R. Well, let's say there's 5 letters. So for the first letter, there's 5 different options, so we're going to put 5 in there. Second letter, there's 4. Third is 3. Next, there's 2. And the last, there's 1 option. So for 5, 4, 3, 2, and 1, so we got 5 times 4 is 20, times 3 is 60, times 2 is 120. So with the extra letter, there's now 120 different ways you can write those letters where order matters. A track team has 7 members, and how many ways could 4 team members line up for a relay race? Now this is the right way to do permutations. You can use permutation notation to represent this problem. We get 7 members, P being permutation, 4, and you're going to choose 4. Now if we were going to choose all 7, we can do like we did in the last problem. 7 times 6 times 5 times 4 times 3 times 2 times 1. But if we're only choosing 4, we have to do 7 times 6 times 5 times 4. We use the first 4 numbers starting from 7. 4 of the 710 members is 840. The expression NPR stands for the number of permutations of n objects chosen R at a time. So let's say you have 9 books and you want to display 5 on a shelf. How many different 5-book arrangements are possible? So really how we would write that is 9P5. So if we were looking at that, what we would do is start with 9 and take the next 5 numbers. So 9 times 8 times 7 times 6 times 5. And we work it out from there. So we would work it out from there. So we would look at that and say, okay, let's multiply these out. And I don't know how to multiply these out. I know how to, but I can't do this in my head very easily. You would multiply those, get your answer over here. So let's see. I'm going to go to my calculator. I got it up here. And I actually do have a permutation button down here. So let's just check it out here. Menu. Probability. I think. Permutation. And I'm just going to say we had 9, 5. We're choosing 5. 15,120. So if we multiply those out, so now if I just go back to my calculator, now I'm just going to show you here, if I went 9 times 8 times 7 times 6 times 5, I got 15,120. So not too bad. So down here now, if we look at this problem, that's a little hard. Let's see if I can, this first one is 5P2. So that means we're going to start at 5 and take the next 2 numbers, so 5 times 4, which means we're going to have 20 different possibilities. The next number is 5P3. So let's say we're going to take 5, 4, take the next 3 numbers, 5 times 4 times 3, which is equal to 60. Excuse me. So that's equal to 60. Next one's 5, 4. So we're going to take next four numbers, 5 times 4 times 3 times 2. And we're going to get 120. And the last one with 5, take the 5 numbers, and we're going to get 120 there. So 5, 4 and 5, 5 are the same. So let's check that out. Let's go on our calculator here. Let's see what happens. If we go to menu, probability, permutation, and we type in 5, 4, we get an answer of 120. Now if we go back and do the same thing again, probability, permutation, 5, 5, we're going to get 122. Now why? Because what's the only number missing off here is 1. And well, 1 isn't going to change the numbers. Now sometimes the order of items is not important. For instance, a ham and cheese sandwich is the same if it's as cheese and ham sandwich. You know, as long as you have your two ingredients, that's all that matters. The arrangement in which order does not matter is a combination. So if we're dealing with combinations, order doesn't matter in the problem. And how many ways could you choose 2 countries from a table when you write reports about inland water? There's a lot of ways. You could choose these 2 countries. You could choose these. If I choose Russia and France, choosing France and Russia are the same thing. So, I mean, there's a lot of different ways as you look through it. So let's try one here. It says, how many ways could you choose 3 different items from a menu containing 6? So really what the problem looks like is 6 choose 3. And that's not a permutation now. This is a combination as we go through here. Now how will we do this problem? This is a little harder problem to work with. Let's just go on the calculator first and to get the answer. There is a combination on a button on the calculator. So we can go probability, combination, and we're going to have 6, 3, enter. We got 20 different ways, so we could just say write out all 20 different ways. And we're going to look at the different ways of doing this problem. Now think about this. What we have 6 items, and we're going to choose 3. So let's say a pop and a drink, or pop and this, or you can list them all off as you go to get your different items, but some will be harder than others. So let's look at how we're going to do this. Another way of thinking about this is we're going to take a combination here is the permutation. This would be equal to 6p3 over 3p3. So in other words, this is a formula for combination is taking the 6p3 over divided by that. So what that means, you're going to take 6 times 5 times 4, take 3 numbers, and start with 3. Now we're going to take 3 numbers, 3 times 2 times 1. Then we're going to get the 20 options out. And we got the combinations as you go through. And so here's the formula for combination NCR. Now, you have 5 choices of sandwich fillings. How many different sandwiches could you make by choosing 3 of the 5 fillings? So on this one, we're going to have 5 choose 3, which if I was going to solve it down, that's a terrible equal sign. So I'll try to erase that. 5 choose 3, which is equal to 5p3 over 3p3. So we're going to have 5 times 4 times 3 divided by 3 times 2 times 1. So if we work that out, 2060 divided by 6 is 10. 10 different ways. I'm going to do one more down here. And let's just do 8, 4. So we got a combination, letter C here. 8 combination 4 could be written as 8p4 over 4p4. So we're going to take the top as 8 times 7 times 6 times 5 divided by 4 times 3 times 2 times 1. Now I can simplify these down and see what I get. This looks like it'd be about 210 over 3, which is equal to 70. So there will be 70 different possibilities there. Now, well, let's look at this one. One more problem, I think. This is the last page, I believe. Yep. Tell which type of arrangement is involved. A teacher selects a committee of 4 students from 25. How many different committees could the teacher select? So we're not even finding the answer to select. This would be a combination. Because it doesn't matter which, she's just selecting 4 students. It doesn't matter which 4 she selects. Now on here, it says class officers are president, vice president, secretary, and treasurer. From a class of 25, how many different groups of officers could she select? This is a permutation. Now, because it matters if you're selected president, vice president, secretary, or treasurer. If one person's president, next time he's chosen vice president, that's a different order. Order matters in that one. In how many different orders could you play 3 CDs? Well, different orders could you play 3 CDs? Order matters, so we'll work on this one. It would just be like 3 times 2 times 1. You could play them in 6 different ways as you go through. Now this kind of gets you started on permutations and combinations, so hopefully they won't have any trouble with this. If you do, bring some questions to me tomorrow. That's not a problem. Thank you.